Welcome, noble world citizens, to planet Earth, our loving home. Professor James Hansen, a leading climate scientist from the U.S. National Aeronautics and Space Administration, or NASA, warns of our planet quickly reaching a tipping point if global warming continues at its current pace, after which runaway climate change will occur. At that time, nothing will be able to save our planet from non-stop cataclysms, such as the total inundation of coastal cities by the oceans, extreme temperatures, and catastrophic storms and flooding that destroy everything in their path. One of the warning signs we are on this path to destruction is the rapid melting of sea ice, glaciers, and ice sheets in and around the Arctic and Antarctic. Disappearing ice causes the reflectivity of the polar ice cap in the Arctic to be reduced. When this happens, solar radiation is absorbed rather than being bounced back into space, resulting in warmer seas, even less ice, and a hotter world. The climbing ocean temperatures are causing a fast sea ice retreat. In 2009, scientists at the National Snow and Ice Data Center in the US estimated that in the Arctic, just 10% of the ice is older, thicker ice, and 90% is newly created thin ice. Today, Professor Peter Wadhams of the University of Cambridge, UK, will discuss the impact of these troubling ongoing processes.
My name is Peter Wadhams. I'm the Professor of Ocean Physics here at the Department of Applied Maths and Theoretical Physics at Cambridge University. Yes, I specialise in the study of sea ice, and I run a research group which works on the thickness and properties of sea ice, motion of sea ice, and at the moment, of course, the climatic effects of sea ice, the fact that it's disappearing. So that involves working in the Arctic and in the Antarctic, using underwater vehicles to measure how the thickness is changing. If you look over the last 20 to 25 years, the Arctic has lost nearly half of its thickness just in that length of time, and this is a bigger loss than the decrease in area. So the Arctic is shrinking. It's also thinning faster, so it will disappear vertically before it disappears by shrinking in sideways. It's reached the point now where the ocean is warmer and the air temperature is warmer, so we're reaching what you could call a tipping point, where the melt in the summer is now great enough that all of the winter ice will disappear and only the older ice will stay at the end of the summer. There's a big jump in the amount of ice that's disappearing every year.
If this pernicious pattern persists, the sea ice will continue to recede until it vanishes completely. Without action, the day of this unthinkable possibility is closer than most of us imagine.
The submarine data and climate models are both showing continuing thinning and continuing retreat. And the models actually show a wide variety of predictions, but the conservative ones are saying that perhaps in 20 to 30 years' time, all of the sea ice will have disappeared during the summer months, especially September. But some predictions are it will happen quicker than that. I suspect it'll happen quicker because lots of new processes come into play. A lot more wave energy is formed because you've got now big ocean areas which used to be ice covered, and the waves come in and break the ice up some more, and because the ice is unconstrained by land masses, it can expand out and break up. The rate of decay or the rate of retreat will increase as the actual area gets much smaller, and until it's like falling off a cliff, it will just all go.
What are some of the other negative consequences of sea ice loss?
The continental shelf areas around the Arctic, here the water is very shallow, it's less than 100 metres deep. As the ice retreats off that in the summer, the water itself can warm up and it's absorbing solar radiation. It warms the whole water column right down to the seabed, and you can get up to about 5 degrees now in the summer, and that means the seabed reaches 5 degrees, and that's enough to melt the permafrost on the seabed, and then the permafrost melting releases methane hydrates that were trapped underneath it. So you're going to get methane releases all the way around the edges of the Arctic in the summer, and they've already been detected around the East Siberian Sea, and probably we'll be getting them all the way around, and that will mean an increase in the atmospheric methane level.
In 2010, a team of scientists led by Dr. Natalia Shakova from the Russian Academy of Sciences studied the East Siberian Arctic shelf and took samples of methane concentrations at various ocean depths. They found that annually, a staggering 7 teragrams of methane is being released from the shelf, with each teragram equivalent to 1.1 million tons of carbon. This quantity of methane is the same amount all the oceans around the world emit each year. Methane has 72 times the global warming potential of carbon dioxide over a 20-year period. Known as one of the shorter-lived greenhouse gases, methane has been identified as one of the most important gases needed to be reduced quickly in order to initiate rapid planetary cooling.
It's a very powerful greenhouse gas, although it's shorter lived than carbon dioxide. So if you have a big pulse of methane, it would have a big immediate effect on global warming, really accelerate it, and the aftermath would last perhaps 7 years before it fades away. We're likely to get nearly all the methane from the continental shelves of the Arctic, and quite a lot from under the tundra on land, all being released within a few years, and that would be a big rise for global warming. All these effects are unfortunately tend to be positive feedback effects, that one effect has a feedback which leads to an increase in the next effect, and that is a case where the retreat of the sea ice, which is mainly due to warming, releases a lot of methane from the open water that's created, and then the methane levels in the atmosphere increase. That increases the warming level, that increases the rate of retreat of the sea ice. Carbon dioxide lasts longer because it's taking part in the carbon cycle. It's being absorbed by the ocean and by vegetation on land, but it's then being re-emitted again by the ocean, having been absorbed into plankton and then released from the plankton again when the plankton die. There's a whole enormous number of different pathways by which carbon dioxide, that's a pulse that you put into the atmosphere, lasts longer because it's absorbed in different ways but then re-emitted again, and it lasts about 100 years. So it takes 100 years for the impact of a big pulse of carbon dioxide to completely disappear. So methane is more potent molecule for molecule, but its effect goes away more quickly.
Another highly detrimental greenhouse agent is black carbon, or soot. Its global warming potential over a 20-year period has been calculated at up to 4,700 times the heat-trapping effect of carbon dioxide. Many studies on black carbon show that it plays a major role in global warming and is another of the main drivers of sea ice loss.
Black carbon is an atmospheric pollutant, and it falls out of the atmosphere, so it's short-lived. When it's in the atmosphere, it's helping to cause absorption of incoming radiation.
When black carbon is deposited on ice or snow, it darkens the top layer, and instead of reflecting sunlight as under normal conditions, the darkened surface absorbs solar radiation, which in turn warms the surrounding area. As a result, more ice starts to melt.
Average sea temperatures have gone up between 0.5 and 1 degree worldwide in the last century, and also average ocean salinities have gone down because of adding fresh water into the ocean from the retreat of glaciers. So there have been two very measurable effects on the ocean, and of course the biggest one is the warming of the ocean, which is helping to cause the sea ice retreat.
A study published by the World Watch Institute in 2009 calculated that at least 51% of human-caused global greenhouse gas emissions come from the cycle of producing and consuming animal products. The cycle includes cattle grazing, which results in vast tracts of barren land that can no longer absorb CO2, and the clearing of precious rainforest that also acts as a carbon sink to grow animal feed. The livestock industry annually generates approximately 37% of the world's human-induced releases of methane. Thus, humanity embracing a plant-based diet would quickly lessen the release of poisonous greenhouse gases that are causing immense sea ice loss and raising planetary temperatures.
There's many ways in which a vegetarian diet would help. I mean, one is reducing the amount of land that's used for looking after domestic animals, and there's massive amounts, especially as the world is tending towards more of a meat diet.
Our appreciation, Professor Peter Wadhams, for your clear explanation of the dangers our planet is facing and the need for the world to immediately address the fast disappearing of sea ice at the polar ice caps. May you successfully continue your very important research that is bringing everyone invaluable information on the state of the Arctic and Antarctic, as well as our Earth's climate. Concerned viewers, please join us again next Wednesday on Planet Earth, Our Loving Home, for the conclusion of our discussion with Professor Peter Wadhams on the state of the Arctic and Antarctic. For more details on Professor Peter Wadhams, please visit www.damtp.camtp.ca.uk/people/p.wadhams. Thank you for your presence today on our program. May we always do our utmost to care for the world.
For more details, please visit www.suprememastertv.com/PE